Good morning, pharmacy.
Good morning.
A little bit of a change today. Miss J is not feeling well. Okay. So I am going to cover the class, and I asked her this morning, if we could just do math and move all your schedules on Thursday, and she said yes. Okay, so we're going to continue where we left off yesterday. I texted Steve if he could come, but I haven't gotten a message from him yet because he's the only one who'll be missing, if ever. So I said, if you can't, that's fine. I'm just going to do a live, and I'm going to record it so that he could catch up. We'll see if he joins us. He might be sleeping because he's not supposed to be here, right? I wish. Okay, but anyway, we're going to do the math. So we will proceed with a 20-question practice problem. It's okay if you haven't done it yet because it's not due until supposedly Friday, right? So we're going to work on it. Okay, since I won't be here tomorrow until 12 o'clock, I'll still see you for the PTCE review at 12 o'clock, please. Okay, I'm very repetitive on that one. So I will tomorrow make time, except for freshmen, okay? Make time to stay. Just to clarify, I think it's always Steve who asks to clarify things. I don't know if he's not listening or is missing stuff. The events on Miss J and I were talking about that. So, like, do I answer? I was asking her, like, you said that many times. I said, I know. So anyway, the events on the app. Okay, the events on the app are there. Thank you, Yami, for being so patient and kind. The events on the app are there for the ones who can't join us. Okay, so the recordings will be there, right? Because not everybody can join us on Wednesdays and Fridays because they work. Okay, and so I put those in there so that whatever recording we have, they can access it. Okay, it's not for you guys who are here. Okay, it's not for you guys who are here. I prefer that you're here. Okay, I'm sure those students who can't make it here prefer to be here than at their work. True. Yemi said true. Yeah. Okay. So we're going to continue where we left off. I know you were supposed to do, so it's Tuesday today, presentations, right? Quiz as well? Okay. So we'll see how far we could go. Okay. And if not, everything will be pushed to Thursday. Okay. If I feel that, okay, they're very confident on this topic now, maybe we could use the last hour or after break on labs. Okay. But for right now, because of our schedule and finals being scheduled on the 19th, I would rather that we focus on math unless you tell me, Miss L, I don't want to do math. That's next week. I kept telling you the schedule, okay? Math is on the 19th, okay? We don't observe, what? President's Day. However, I will be out on President's Day and on Tuesday as well, okay? So I'll be out Monday and Tuesday. It's not a fun, like I'm going on a vacation out. Okay. It's not a fun, I'm going on a vacation out. I wish it is, but it's not. It has something to do with paperwork, documents. Okay. It's not a fun thing that I'm going to be out for 2 days. It's something that I've been pushing, but it's important. Okay. So, anybody objecting on math today?
No.
No one? No one?
No
Okay.
math.
Miss J will be here tomorrow, hopefully. I'm not sure if she can be here tonight, so I'm bracing myself as well to teach up to 10 p.m. tonight. I know. That's what happens, okay? But we have very good teamwork. I'm in pain, but I don't show it, right? I have lower back pain really bad right now. But anyway, The show must go on. So we're going to do math today. Tomorrow, she's going to take over the class, my class. Whether she's going to do labs flip-flop tomorrow or math is up to her. Okay, but I'm going to give her a heads up as to where we are on math by the time we finish today. Hang on a second. Thursday, you go back to normal schedule. Labs, which means whatever you missed today. So if we don't get to presentations today and we don't get to quiz today, that means Thursday is going to be the drug words and abbreviation quiz and the presentation as well. Okay? Or she can do it tomorrow. Just be ready because we're just flip-flopping our class. Okay? I don't think there's anybody who needs to be here for labs. Like Alex is moving, different session. Okay? And then Friday, I will be back. Okay, I hope by Friday you're really very strong on Alligation because I won't be here Monday. But of course, Monday, Miss J is still going to do a review of math because finals is on Wednesday. Okay. Why are we doing a lot of this review? The grading scale changed. Okay, so even more so, if you're stressed, I'm more stressed. I'm more stressed. Why? Because based on history, allegation is not something that clicks right away with students. Okay, not because they didn't understand, but most of the time they just need extra time. Okay, but when I heard you guys yesterday, like almost half the class said the same thing. It's like boom, like an aha moment. I kind of have that confidence, like, whew. Right? Okay. So finals. Okay, I don't know if that's Steve, but there's two people right now in there. Finals is 35% of your final grade. It's not 20 anymore. If you notice, I updated your math grade yesterday.
Yeah, I know.
Okay. So here's the thing. If you fail finals, you fail the class. Because that's 35% of your grade. Okay? So what I'm trying to do before next week is to put in one more quiz, day supply and quantity to be dispensed, not allegation. Okay? That's easy. One more quiz so that we can bring your grade up. Because participation-wise, I put a lot of you are participating. Did you see that? So I gave you full points on participation. Okay? I only checked the homework on the first part. Okay? But we killed 88 people on the conversion test. Right? So there's a big chance that some of the students in this class will fail. Big chance. You saw the numbers yesterday, right? Okay. Like you saw, those are individual, how many missed. So there's somebody who missed 29 questions. There's somebody who missed 11 questions. Okay, and that's just conversions. If you failed that quiz and you failed finals without me doing the math, what do you think is going to happen? You are going to fail. Yeah, no matter how much participation I give you. No matter how much participation I give you. So if you're stressed, I'm stressed. I don't like putting a failing grade. I don't. Okay? Some of you think I do. No, I don't. But you make your grades. I just record them for you. Okay? I don't like putting a failing grade. So that's on you. Okay? You have so many resources. Okay? Let's start. Good morning again.
Good morning.
So we did 1 and 2. We're doing the 20-question practice problems before we jump to the 8-page practice problems. Okay? We're going to do this one first. Who did it? 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 You don't have it?
No,
You left it on your desk?
Yeah, because I thought we had Miss J's
I know, it's okay. That's why I said when I woke up, I saw 7 messages from her, or 6 messages from her. So she also has vertigo like I did. And it's the first time, so she's so scared. She's so scared. She said, oh my God. I said, just rest. Don't drive. Okay? Hopefully it goes away. Get a meclizine, okay? It's scary when it's the first time. It took me 2 months to recover from my last attack. I had remember I called out? Were you here already?
No, he wasn't here.
Dr. Valencia, because Miss J wasn't here too. She was on PTO, remember? Dr. Valencia had to take over the class. Yeah, so to me, it's something that happens like once in a blue moon, but when it happens, it's bad. The whole room is spinning, okay, throwing up. So I told her to have to DoorDash meclizine and just rest. That's why she doesn't know if she can make it tonight. And so I'm bracing myself to cover the night class. Okay. And then tomorrow, I hope it doesn't go. She said the room isn't spinning, but every time she gets up, she's dizzy. So it's either an orthostatic hypotension, which means you stood up so fast, then you got dizzy, or another possible problem is an ear infection when you get those. Okay, but she's so scared. Anything that's the first time, not familiar to you, you're scared. Okay, I get it every few years. So when I fly, which I still do, okay, I have a throw up bag in front of me ready, a barf bag ready. But I also take scalp patch and a meclizine before I get on a plane, get on a ship. I do those things. Okay, it helps. Even when we went to this sphere, Miss J and I said, "Hold my hand, huh?" Because I just had a vertigo attack when we went to the sphere. And so I don't know, that's like a 360 thing. So I had ginger the whole time when I'm traveling, ginger juice. That's why you see me, I always have a bag of ginger juice. When I travel, I order ginger ale because ginger helps with your vertigo too. So I order ginger ale, the first thing I order when I get on the plane, okay? And then I'll have ginger juice after ginger juice after ginger juice. Anyway, I'll try to focus this on the board. Let me see, Justin, if I have extra blank sheets for you. Who else doesn't have it? Justin, I have extra.
Oh, thank you.
You just have to do it. But if you did it, you know how to do it. Who else left theirs? Anyone who's you guys are so quiet. Tell me if you object on doing math today.
No, but you got
we need math.
that's the other problem.
And I want
I just I got the TikTok.
Like I said, if you're stressed, I'm stressed for you.
Plus, I want to learn math so I can know the stats so I can pass my final.
Okay.
And
Yes, that's why I want to do a lot of examples. Okay. A lot of examples. Miss J came back yesterday. She said, "Are you okay?" Because she knows I was in pain yesterday too. I said, "I made it through 4 hours." I really don't like doing math 4 hours because to the ones who love math, yeah, that's cool. But to the ones who are struggling, you need to take a break from it. Okay.
So,
What is it?
do you have a copy of this one? Because I don't think I didn't get it.
That was in line right there, right?
Must.
That's not what we're doing yet. So if I don't have it, I'm gonna. Oh, great.
Yeah, I was trying to look for this one. I was like, I know I grabbed it, but I don't know where I put it.
Okay, just like you were giving your worksheet to Yami yesterday.
Okay, that was my mistake.
How could you not know your handwriting and give it to Yami? Yami, he wanted you to do his homework.
I thought I put it in my backpack too, so.
Yeah, he's like, this is not
I thought,
handwriting.
here, I was like, did I put it in my backpack? That would equal up to.
Okay, let's do number 3.
Number
We
3.
did yesterday.
Oh, we did?
Yeah.
No, for me.
200 milligrams per ml. We did number 3 yesterday. Okay, your final answer will be 0.2 grams per ml, correct? But you always have to look for the question and answer the question. Right. A percentage will always be in, if it's weight, grams, if it's volume in ml. So whatever final answer you get, if it's weight over weight, will be grams over grams, right? If it's volume over volume, it'll be ml over ml, okay? If it's weight over volume, it will be grams over ml. So solving number 3 would give you 0.2 grams per ml. But is that the question?
No.
So there should be an extra step, correct? Which is to convert, simple. Okay, that's why it should be strong in conversion. Simple, which is convert your 0.2 grams to become milligrams. Is that clear?
Yep.
Okay. I wanted this fill in the blank, show your work problem so that I know that you understand it. Though the final exam and the PTCE is multiple choice, it's easy to guess, right? But if you guess it wrong because you didn't understand, yeah, it's not a good thing, right? So I want to know that you understood the topic. Did we do number 4 as well?
No.
Okay, let's do number 4. Okay. Remember, I told you, the PTCE, a lot of students who took it say, oh, I have this many allegations, but apparently they're not allegation questions. They're concentration or strength questions. And there's a lot of those. Okay? Because allegation is a tic-tac-toe method. Remember? So if you see 3 strands, use the allegation method or the tic-tac-toe method. If you see 2 strands from a higher concentration to a lower concentration, what do I personally want to use? The formula for dilution. C1V1 equals C2V2. You have to remember that dilution is from higher concentration to a lower concentration, which means to check your answer, your C1 should be higher or lower than C2. It should be higher, but your volume should be what? Lower. Think of it this way. For a substance to be strong, there's less liquid or less water. So they're inversely proportional. Are you following?
Yeah.
That's why I drew the arrow. 2 concentrations, there's water missing, okay? C1V1 equals C2V2. There's 3 concentrations, you have to use the tic-tac-toe method. However, if you love the tic-tac-toe method and it's a dilution problem, you may use the tic-tac-toe method using water, what percent? 0% as your lower concentration. You following? Okay. And if it's a pure substance, what do you use? 100%. Yeah? Okay. So you can use tic-tac-toe for dilution as well. Okay? Let's try to do number 4. Remember your powder volume? What's the formula for powder volume? Final volume minus initial volume. What do I want you to remember when we're talking about powder volume? Remember the beaker. Okay? There's 100 ml level on the beaker. Water. You add the pebble. Okay? What happens to the level of water? It rises to 110 ml. You following? Why? Because the pebble or whatever substance we're talking about has weight or mass that makes the level of water rise, right? In pharmacy or chemistry, this can be any substance, specifically powder, that dissolves in water. You following? Why do I not have? So, what happens? What's the formula for powder volume? Final volume minus initial volume equals powder volume. We also call that powder displacement. In other words, okay? What happens? 110 ml minus 100 ml is 10 ml. This pertains to what? The powder volume of whatever substance you dropped in there. Because it made the water rise, right? It dissolved, okay? Remember the terminology. So solute is the substance to be dissolved. Solvent is the dissolving medium. When you add the two together, it creates a solution. Solvent can also be termed as diluent. diluent. So if you see the word diluent in the word problem, it's the same. Who's done IV? Hands up. All of you are certified except for the freshmen, right? You remember your yellow powder in the vial? That's what you call a powder for what? Dilution. You dissolve that because you cannot inject a powder, right? You have to make it into a solution form, okay? The water, sterile water for injection that you add to dissolve that powder is called a diluent. The powder is the solute. The water is the diluent or the solvent. You shake it. What happens to the powder? It dissolves and creates a solution. Whether that powder for injection or the one that is for oral, though most orals are for our suspension. Okay, suspension doesn't dissolve fully. Right? Solution dissolves fully. Powder. That's why I like using the vial as an example, because you've seen it dissolve, right? Right in your very eyes. Okay, so those terminologies are important. Okay, if that powder for on the label, it will say how much diluent you add to create this strength. The more diluent you add, the less strong. Okay, and strength of the drug or concentration of the drug can be in percent, but it can also be in fraction form. Remember? Because it's grams over grams. Ugh. I have to go get some. Because it's grams over grams if we're combining two solid or semi-solid. The word is ointment, usually. What you're going to see in the problem. Creams, lotions. Right? So we can combine two solids or semi-solids. That's why your strength can come in fraction form. You want to make it a percent, you multiply that by 100. Okay? If you combine two liquids, that's volume over volume. Combining two liquids that dissolve each other, that are miscible, is a solution still. Some liquids don't mix, like oil and water. We add what we call a surfactant. Okay? For water and oil to mix. Okay? Just like think about your pan and you use it to fry. Okay? What's a surfactant? Soap. That's how you mix oil and water. Okay? But we don't mix soap in substances because we digest it, right? Anyway, volume over volume. And when it's volume over volume, this is your weight over weight, right? When it's volume over volume, it will always be in ml over ml. You want to make it a percent, it's going to be times 100. Yeah. But the most common one is when you combine a solute, just like your vial. Remember, yellow powder. Over a liquid. Solid combined with a liquid, and that solid in powder form will dissolve. You want to make this a percent, you multiply it by 100. You following?
Yes.
Okay? Another thing, sometimes on the PTCE, it will come out as ratio. Can we do that? Yes, because this is a fraction. So when you say 1 gram per ml, what is that in ratio? 1 is to 1 per ml. Okay? 1 is to 1, right? But when you say 1 gram for every 100 ml, what is that in ratio? 1 is to 100. So a 10%, make it into a ratio, because this is a common problem in the PTCE. What do you think this will be? So you turn this into fraction first before you turn it into a ratio. What is this? You can do 10 grams, right, over 100 ml. Remember my lecture yesterday? So what's your ratio? 10 is to 100. Reduce it. 1 is to 10. You following? Sometimes the problem is in ratio form, and I don't want you to get stuck. So if you see that the problem is in ratio form, right away you know that there's an invisible G there and an invisible ML there, no matter what. And this is how they're going to test you as well. They're going to give you in milligrams. Right? But don't get tricked by that, because a percent and a strength will always be in grams, okay, if it's solid, if it's solute, and in ml if it's volume. Are you following?
Yes.
So even if that's showing, you gotta know, you have to know that that's grams over ml. Invisible, okay? They will throw questions in ratio form. I think there's one or two in here. In the problem. Is there a ratio problem in here? Number 4? No. An actual ratio problem. I'll give you an example later once we're done with this one. Okay. You didn't see any. I'll give you an example. I think it's in the 8-page one.
Okay, probably.
Yeah. Okay. Do you understand? Yes? Okay. That's why I started with a whole number can be converted into a fraction. A fraction can be converted into a percent. And a fraction means a ratio. But you always have to remember there's an invisible unit in there. If it's weight, it's grams. So if you see the word ointment, that's grams over grams. And if you see the word solution, most likely that's grams per ml. Unless they specify that's volume over volume. You following? Remember this one. Okay. Number 4. Who wants to do number 4? The label of, can you write the problem on the board too when you're doing it? The label of a 10-gram vancomycin vial states that if you add 95 ml of sterile water to the vial's contents, you will give a concentration of 1 gram per 10 ml. I think that was one of my examples.
Oh, I think it was. I see it.
What concentration do you get if you add 45 mLs? Give me answers. No. The question was, what?
What concentration do you get if you add 45? So it has to be an answer similar to when you add 10.
Exactly. You're missing something.
I thought 55 grams of volume. I did the final volume, it is initial volume, it was powder volume. It is one of the
You're missing something. 10-gram vancomycin vial states that if you add 95 ml of sterile water to the vial's contents, it will give you a concentration of 1 gram per 10. Which means how much is the powder volume to make it 1 gram per 10 ml?
10.
How much is the powder volume?
95.
10 grams. 10 grams is
What's your solute?
sterile water.
Solute!
Oh, so
The vancomycin. Okay? Remember, your numerator is always the solute. Right? And the denominator is always the total. Total solution, total weight of the substance. Following? Okay. So to begin with, you got 1 gram. What's the concentration? 1 gram, which I wrote a while ago, to 10 ml. You want to convert this to a percent? That's fine. Right? Or You want the duration proportion. 1 gram is to 10 ml. As to 10 grams is to X ml. Why? This is your concentration. It has to be exactly the same as your 10 grams for you to know that this is what? 10%, right? Concentration. Or 1%. 1 divided by 10 is what? 0.1?
Point zero.
Point-
0.10.
0.1. So percent would be 1, 2. It's 10%. Anyway, going back. You have a concentration 1 gram per 10 ml, right? You have a solute. But you don't know how much the total that is. You just know the diluent, which is 95 ml. The diluent doesn't include the dissolved powder. Right? You have to figure that out. And what is the answer here? Your X is 100 ml total solution. Now you're talking, right? So how much did this 10 grams dissolve into? Final volume minus initial volume. Exactly. So what happened here was what? You have 95 ml water. You added the powder. The water rose to 100 ml. Which means this is 5 ml. The powder that dissolved was 5 ml. Are you following? Because a percent will always be total on the denominator. Right?
Yes.
Now proceed to the next step. Are you following? It just told you the water part. It didn't tell you how much the total volume is. So you have to dissolve that powder. The 10 grams after dissolving amounted to an extra 5 ml is what it's telling you. Are you following?
Yes.
So if it asks you what's the powder volume, the answer is 5 ml. Okay, that's not the end of it yet. What's next? So you figured out that you have to add 5 ml so that you can keep that concentration of 1 gram per 10 ml. What concentration do you get if you add 45 ml? What concentration do you get? What did you get out of that? The powder is not going to vanish. It's not going to evaporate. You understanding?
Yeah.
What's going to happen to the powder? It will dissolve. Remember the pebble? If you drop the pebble, it will rise the level of water. So it's only telling you the amount of water is 95, right? But if you do a proportion at 10 grams, to make it this concentration, the total volume will be 100 ml, total solution, okay? This is just the water part, okay? This is just the water part. The 10 grams of vancomycin dissolved to add an extra 5 ml. That's why it became 100 ml total solution. Are you understanding? This is just the first step.
I need to go see you take it. I need you
Okay.
to walk through it. I need you to walk through.
Let's reverse it. This is your vial. There's powder here. This powder is 10 grams. Okay? What did the problem say? You added 95 ml of water. Water. Your diluent or your solvent. Do you think when you dissolve this, it will just be 95 ml?
No.
That's what I'm
No,
saying.
we understand, doctor.
Right?
We understand.
That's what we're saying. So the water's just 95. It will create, based on this concentration, because it says that if you use 10 grams, the total, remember, the denominator is not just the water part. It's always total solution. Okay? If you use 10 grams, to make it proportionate to this concentration, 1 gram for every 10 ml, the total volume, which is the combination of the solute and the solvent, is 100 ml. You just calculated that first part. You follow it? Yeah. Which means a 10-gram Vanco will dissolve into a 5 ml powder volume. Correct? So now you're given the second step.
So is that adding 45 onto the original 100 ml? Or is that?
Okay, read the problem. The label of a 10-gram vancomycin states that if you add 95 ml of sterile water to the vial's contents, you will get a concentration of 1 gram per 10 ml. Correct? Okay. Who knows where the yellow powder is? Can you give me one? What concentration do you get if you add 45 ml? So will your solute change? Yes. No, it will not. No matter what, there will be 10 grams of Vanco in that vial. The concentration will change. Yeah? So what's my numerator? 10 grams. What's my denominator? 4. Read the second sentence. Give me the yellow.
It's XML.
What? Read the second sentence. Are you still gonna add 95?
No.
So what are you gonna add?
45.
Will that be it?
No.
What am I gonna add more? At the bottom. So these are two different situations, just so you know. This vial has 10 grams, okay, right? But you added 95 water, okay? And it became 100 ml so that it becomes 1 gram per 10 ml, correct?
Yeah.
I do know what happened to this 10 gram vial contributed to 5 ml. So another situation, I still have 10 grams, right? Because the vial comes in 10 grams via Vanco. That's your numerator. But this is a different scenario. You add how much water was the condition this time?
45.
Plus 45. What's the denominator should be? What should be the denominator? Just 45 ml, just the water? What did you realize on the first one? That every 10 grams of Vanco dissolves into what?
Oh.
Dang, man.
Give me a vial.
I can't find one.
Why are you stuck here? The vial will have 10 grams of Vanco no matter what. The question is, how much is this in terms of concentration? Now it's going to be 10 grams for over 50 ml, because your denominator will always be total solution, not just water part, but the actual dissolved powder.
There's no power.
It's okay. Yeah. No shoppers, there's no labels too. Because I wanted to show you in the old one, thank you, Justin, there's a table. If you add this much water, this will be the concentration of this vial. But if you add this much water, this will be the concentration of this vial, okay? So I want you to find one of the older vials. It will have that table. So you can picture that. But do you understand what I just did? The first sentence is just for you to realize that a 10-gram Vanco dissolves to become 5 ml. That's how important powder volume is. In your second scenario, you still have 10 grams Vanco. It will still dissolve into a 5 ml as your powder volume. But remember, your denominator can't just be water part. It is a total solution. So you have to add that powder volume in there. And what does this become? 0.2 grams per. What if it asks you, how much is this in milligrams per ml? Very good. 200 mg per ml. Do you understand that? Do you? I'll give you a chance to absorb it. While Justin looks for that. It will have a table, Justin, on the label. It's one of the old vials. Do you understand this, Justin?
Yeah, I think.
Okay, so remember we started with grams over ml, and this is grams of solute over total volume of solution. I didn't say water or diluent. I didn't say solvent, which means your denominator is the total all the time, okay? And the concentration is in percent, in fraction, in ratio. Did you understand this, Ashley? A little bit. You still haven't found it.
Only one I could find is like this.
Who understood it?
Because it just
The label is so tiny.
because you know this one. I just used to
Okay, let me go back again. A concentration can be in percentage form, but it can also be in fraction form all the time, right? And there are 3 possible concentrations in a substance. Weight over weight, okay? Weight over weight, okay? Volume over volume, which is ml over ml, and weight over volume. But you have to understand that the numerator will be the amount of solute no matter what. So you have to know how to identify which is which. You following?
Yeah.
And the denominator will always be total. The combination of the solute and the solvent. Because it's total amount or total weight, in this case, of the compound. In this case, total volume, okay, of the solution, because it's the combined solute and solvent. Okay? And this one will be the total volume of the solution as well. Okay? So we told you that this is the strength or the concentration of the drug, which is this one. You following? Which means this is weight of solute, 1 gram, and this is the total volume of the solution. You following?
Yes.
But you should have identified that 10 grams is solute, right? 10 grams of Vanco. Okay? Now you make a proportion because you want it to be the same exact concentration, right? So you have to figure out what is the total solution for me to create this concentration. And you figured out that that's 100 ml total solution, right? There was a given in there. Part of this is 95 ml water. You following? But how did it become 100? What does that tell you? That the 10 grams of Vanco dissolved to become 5 ml part of that. That's how you got the 100 ml as your denominator. Because your denominator will always be total when we're talking concentration. Are you following? Now there's a second scenario, right? It's asking you now, because this is a concentration, right? For the 10 grams Vanco over 100, that's the proportion, right? Following? The second scenario is no matter what, you're still going to use a vial that has 10 grams Vanco, because that's how it comes in, right? Now you have a solute. Do you have a solution? No. Right? But there was a condition on the second one. What's the condition on the second one? How much water did you add? 45. Will that be your denominator? No, because you know that this 10 grams Vanco will dissolve to make 5 ml. So because I kept saying, because that's the formula for concentration, your denominator should always be the total. So will you use a 45 ml or will you use a 50 ml?
50 ml.
A 50 ml. Is this a concentration? Yes, grams over ml. What did I say? This is a concentration, this is a concentration, this is a concentration. If I ask you, there can be a follow-up question. So you came up with 0.2 grams per ml, correct? This is correct. But what if the multiple choice options are in milligrams? This is correct. But what if the multiple choice question is in percentage? From which one? Here or here? Yes, because your percentage should always come from here, or grams over grams. So times 100 would be 20%. Did you just see that? If the options are in grams per ml, you choose this. If the options are in milligrams per ml, you choose this. But what if the options are in percent? You choose this. They're one and the same. But you have to remember that in concentration or strength of the drug, your denominator is not only water. It is the total solution. Are you following? Let's go back. Solute is the substance to be dissolved. Are you following?
Yes.
Usually in powder form. It can come from a tablet that you crushed or triturated. Okay? It can be in a vial, just like your yellow powder in vial form. It can be a suspension, just like the powder in amoxicillin. Are you following? Okay? The substance to be dissolved. Solvent is the dissolving medium, usually water. Needs to dissolve that solid matter, also called diluent. You following?
Yes.
You combine solute and solvent, what happens to the solute? It dissolves if it's 100%, like it can dissolve. Okay, right? It'll dissolve. If it's a suspension, you don't expect it to dissolve 100%. Yeah? If this solute turns into a solution, that solute will dissolve. Okay? to create a solution. And you have to remember this strength, the denominator is in solution, total, not just the water part, but the combination of the dissolved product, which is the solute, and the solvent. That's how we got the 45 plus 5 as the denominator, not just 45. Are you following? Okay. If it's ointment to semi-solids, it will be weight over weight. Grams of the powder that you put in Vaseline. And then you do the flip and fold method. You remember that compounding? Okay. If it's volume over volume concentration, that will be 2 liquid substances that mix together. You following? If it's a solution, which is usually the case, most problems, most solution come from powder dissolved into a diluent, becomes a solution. That's grams over ml. But you have to remember your denominator is the total, not just the water part, not just the solute part. Are you following? That's how we got the 45 plus the 5 as the denominator. So your concentration can come up as a fraction. Did you see that? But any fraction you can convert into a percent by multiplying it by 100. But you have to remember this has to be G and this has to be ml, or G over G, or ml over ml. But this is the most common one, G over ml, grams over ml. Are you following now?
Yeah.
So there are 3 possible answers. They're all correct. They all mean one thing. Okay? So in a multiple choice question, you can be given this answer. And this is the correct answer if it's in grams per ml. You can be given all milligrams per ml options, and this is the correct answer. Yeah. But what if the options are percent? This is the correct answer, because this will be 0.2, 120%. Who understood it? Okay. Do not raise your hands if you're just like getting forced or what is that? Peer pressure? Okay. I have to know if you understand it, because you're cheating yourself. Keep raising your hand, you keep raising your hand, and then you bomb the test. Who you joking? Who you cheating?
Not me. No.
Right?
I bomb.
How you doing?
How can I help you if you know it?
You said no, please.
Keep raising your hand. You kept raising your hand, and then you show me a test that you bombed. Who's that? Who you joking? Who you cheating? Yeah? Who understood it? 90%. Okay. Who understood it? 50%. Who didn't understand it at all? I cannot explain it simpler. I tried. Okay? So can somebody explain it simpler after I kept saying this and spitting this out for 3 days now? The basics. Right?
So we have used the formula.
This shows up a lot on the PTCE. That's why I said it's disguised as alligation, but it's not alligation. It's a concentration, because it wants you to know if you know how to calculate the strength of a drug. Can we use what?
The final volume times 20 equals weight. Because we were given the weight, which is 10 grams. We're looking for the percentage. And if we know the final volume, which is 45 plus 5, matching this number in the formula and get 22.
Can you do it on a board? It's harder for me to picture what if you're talking about it, but it may be easier for me to understand if you show me the work. That's for other problems.
So this weight is not.
You're not going to calculate any weight. Why? It's given. It's in the vial. The vial will say, this is a 10-gram vial. This is a 10-gram powder for reconstitution.
I think what you need is, can't you just work the formula to give you the percent, and from the percent you can find out.
Oh, later, there are problems like that.
But you can't use it for this problem.
You cannot use it for this problem.
That's what his question is.
Because this is a two-step problem. But if you don't understand the basics, which I've been harping on, of concentration, weight over weight, volume over volume, or weight over volume. What concentration is this? Weight over volume, which is the most common one. You dissolve a powder to become a solution. Right? You don't have to calculate the solute in this problem. Why? The vial will say, hey, I'm a 10-gram vancomycin. Do you have to calculate me? I said, hey, I'm a 10-gram vancomycin. Now answer me, do you have to calculate me? No.
No.
I freaking said, hey, I'm 10 grams, like Fabian will introduce. I'm Fabian. No, I'll have to think what your name is.
What does it mean?
Hi, I'm Yanni. I don't think so. I have to calculate what your name should be. The vial says, I'm 10 grams vancomycin. Do you have to figure me out? No. Right? And the vial says, if you add 95 ml water to my vial, I will become a 1 gram per 10 ml strong. What's 1 gram per 10 ml? For us to picture that in percentage. 10%. If you add 95 ml of water to me, I will become 10% strong. How did I become 10% strong? Well, if you add 95 ml water to me, I will become 10% strong. 1 gram per 10 ml, right? But I'm a 10-gram vial. So how much total solution is that so that we're the same? Well, my total solution should be 10 ml. How did that happen? I only added 95 ml in the vial. Because, hey, the 10 grams became a liquid form. And that 10 grams amounted to what? 5 ml. Now I know that, right? So here comes another vial. I'm still a 10-gram vial because that's how the drug comes in, right? So what will be my solute? 10 grams. What did you figure out in the first scenario? That 10 grams will dissolve into 5 ml no matter what. The second scenario says, add 45 ml into my vial. I will dissolve and become 5 ml still, if I'm talking about the Vanco. So since the concentration or strength is based off grams over total ml of solution, my denominator should be the water that you added to me plus the 10 grams that dissolved into F5. Now the question was on the second scenario, what is my concentration? And what are we talking about when we're concentration? Grams over ml, or percentage, or ratio. Right? So when you solve this, you will come up with an answer 0.2 grams for every ml. You following? In ratio, 0.2 is to 1, or 1 is to 0. Can't be 1 is to 0.2. 0.2 is to 1, right? Because a fraction can be converted to a ratio. If all the options are in milligrams, you just convert your grams to milligrams. So this is the correct answer too. Okay? But what if the options are percent? You go back to here because percent will always be either one of these 3 times 100. And that's why the correct answer is 20%. Are you following? I did say that concentration is solute only as a denominator. Concentration will always be the total. Are you following? Okay. So this is how it will look like in a vial. There's going to be a label. Are you done? Because I want to erase it. Scrambling
Yes.
everything in there. I want to show the table first that you will see in a vial. That's a real one. And somebody erase the board if you're done.
Hey, like we all want to race the board. Oh, they're so excited to race the board. Nice.
Did you understand how these are all correct answers?
Yes.
Yeah.
Depending on the multiple choice question?
Yes, I see.
Thank you, Danny. If you don't understand the concept of concentration,
Yeah, you're gonna fail.
you won't understand what I'm talking about. So to those of you who don't understand, you don't understand the grams over grams, grams over ml, ml over ml. You don't understand that that can be converted to percentage. You don't understand that that can be a fraction. You don't understand that the concentration is the strength of the drug too. And you don't understand everything that I said, that the numerator will always be solute and the denominator will always be total. So it can't just be 95 only. It can't just be 45 only. Okay? So you have to go back to that video. This is your vial enlarged. Okay? You will say vancomycin here. You following?
Yes.
And it will say 10 grams on the label. Or whatever drug is. Okay? Hey, I'm 10 grams vancomycin. No, you're not. Hey, I'm Josh. No, you're not. The label says I'm 10 grams vancomycin. Right? Okay. At the back of the label, you will see this. Actually, just check. Dilution instruction. Okay. Water to add concentration. Okay. Water to add concentration. If you add 95 ml water, I become 1 gram per 10 ml. If you add 45 ml water, I become 0.2 grams per ml. Right? But for you to calculate the concentration, you know that this powder will dissolve into something. Right? So, your 10 grams, you don't know how much the total solution is. But it told you that 1 gram per 10 ml is my concentration. Are you following? 1 gram per 10 ml is my concentration. 1 gram per 10 ml is my concentration. Okay. But I'm not only 1 gram, I'm 10 grams. So this is X ml. Is this just the water part? Is this just the water part?
Yes.
Is this just the water part? Or is it the total solution?
Total solution.
It's the most common mistake students make on PTCE in the finals. Because how many times do I have to say that the denominator is not just the water part,
Total solution.
it's the total. So for you to know this concentration, just gave it to you, you have to figure out the total solution first. Cross multiply, it should give you, without doing the math, I know there's an extra 0, so it's 100 ml. Again, this answer, is this just the water part or the total solution part?
Total solution.
Okay? But I do know based on this table that I only added 95 ml. Which means 95 ml is the water part. Where do you think the 5 ml came from?
So
Your 10 grams Vanco. Okay? So now you have a working number and you know that this powder will turn into 5 ml when dissolved. Based on a 10% concentration or 1 gram per 10 ml concentration. There's a second problem though. Get another Vanco, right? It says add 45 ml water. Okay, so that other Vanco, no matter what, will have a label, 10 grams, right? What's my denominator? Based on the problem. I need water, 45 ml, but I've figured from the first scenario that this 10 grams Vanco dissolve into 5 ml because my denominator should always be total. The question is what concentration? You didn't know this, but this was given in real life on a table form. If you add this much water, it becomes this. If you add this much water, it becomes this. Are you following? So what it will show is actually 200 mg per ml. Okay? How did that happen? Well, we calculated that earlier. I'm just doing it in reverse. So 10 divided by 50, there's your grams over ml, right? Is 0.2 grams per ml. Remember, this can be invisible, but you have to remember if it's in fraction and it's a concentration or a percent, it means it's grams over ml or grams over grams if it's an ointment or semi-solid or ml over ml. Okay, but most of the time it's grams over ml. So that is 0.2 grams per ml. But what if your options are not grams per ml, but instead milligrams per ml? Convert your grams to milligrams, then this becomes 200 mg per ml. What if your options are percentage? You go back here because percentage is based on grams per ml times 100. So this becomes 20%. What if you're given 20% and it asks you how much solute is this and how much solution is this? Tell me, convert this. A 20% means that there's blank solute over ml solution. $20 grams of solute for every 100 ml of solution. You remember that? From the first lecture. That's why you have to understand that lecture first. Remember again. grams over grams, ml over ml, grams over ml. You might want to make this percent, you multiply this by 100. You following? But this is also exactly the same as grams over 100 grams. You remember your dextrose 5% in water? We did a lot of practice on that. And so this becomes ml over 100 ml. And so this means grams over 100 ml. I asked you before, what's D5W? You said 5%. Now tell me how much dextrose is there into how much solution. D5W you said is 5 grams of dextrose for every 100 ml solution. You have to know this basic or you won't understand anything that we're doing moving forward. You see how I keep going back to the first lecture on concentration? Many major exams is not a test of skills. It's a test of comprehension. The skills you can learn when you're out in extension. It's testing whether you understand what it's talking about, what it's asking you. Okay. I don't know if you remember what I told you. Like in pharmacy exams, so it's multiple choice. There'll be 4 options. Okay. All of them are correct. But there's only one best answer. And that's what you should choose. All of them are true statements. There's only one best answer. And what is the best answer? The one that answers the problem. The one that answers the question. That is it. Okay? That's why I kept flip-flopping. What if the options are this? Grams per ml. You choose this. But you shouldn't be stuck there. What if the options are in milligrams per ml? You just convert it next part. What if the options are in percentage? Well, you just convert this to percentage. And what is the foundation of that? Right here. Common mistake, the denominator, students just use the water part. Remember your tic-tac-toe? It's not just the water part, isn't it? There's the active ingredient part. There's the water part, and then there's the total solution part. You following? Who understood it? Because I'm going to move on. The label says I'm a 10-gram Van Coke. You don't calculate me. I'm telling you I'm a 10-gram Van Coke. You don't calculate this solute anymore because it's given. You following? Any of these problems can be done in reverse. That's why I tell you, what if the question is? What if the question is? What if the question is? Okay? That's why I'm trying to train you to answer those questions straight to the point. Answer what's being asked of you. In this case, you can have a 0.2 grams per ml answer because it's a explain your word question. But if it's a multiple choice question and it doesn't have grams per ml options, are you going to be stopped? No. Yeah. If it's a milligrams per ml question, you should be choosing 200 mg per ml. What if it's a percentage question? You should not be stopped too, because you know from the first lecture on concentration that no matter what, you can convert that to a percentage by multiplying it by 100. But if we do it in reverse, you're given 20% concentration. It asks you how much that solute is. You can say that it's 20 grams. Because that you know that 20% means grams over 100 ml. You following? What if my if solute is 40 grams, but I'm a 20% solution? How much is my total solution? Based on this problem. If I'm still 20%. So if I double the numerator, what should I do with the denominator?
So,
Just double it. So try doing it. 40 divided by 200 times 100 will still give you 20%. That's why most of the time I look at a problem, it double the solute. I'll just double the proportion. Right? If you overthink it, like, oh, cut it in quarts. I should cut it in quarts. You following? And that's why you see people who don't do the math, they do the math in their heads. And they're having a hard time explaining it to you because they just see it. My son's like that. It said, I got him a calculator. It said, I'm like, how come you've never touched your calculator? And then I put scratch papers next to him. Like the scratch papers are still clean. And he just does it in his head. And he was explaining it to me, Mom, look. This was divided into 4, so the other side should be divided into 4. I said, it's just easier for me, Mom, to do it in my head. There are people who are like that. Okay. I have to use a paper and scratch paper to double check my work. Because I don't want to fail. I wanted the correct answer. Get it? But sometimes what we do forget is to step back and look. Oh, her example was 40 grams. She doubled the solute. And it's still 20%, right? So I need to double my solution to make it still 20%. And step back. Look at it, just like what Justin was explaining to Calvin. $1. Remember that? So a quarter, 3/4 is 75 cents, which means 75%. $1 is a whole. Okay. Who understood number 4? Moving on to 5. The pharmacy has received a prescription of 30 grams of a triamcinolone, 2% ointment. How many grams of triamcinolone will you need to prepare this prescription?
0.6 grams.
Correct. Correct. It can be as simple as convert your percent into a decimal, then multiply it by 30 grams, because your word off means times. Or you can do ratio and proportion if you want to, but convert your 2% to 2 grams over 100 grams equals X grams over 30 grams. Did you see that? Ointment. So it's going to be this one. This one. Did you see that? That's why I said watch those words. I'm giving it away to you. 2% means 2 grams for every, because it's ointment, 100 grams. You want ratio and proportion. What was given? 30 grams, but do you put that in the numerator or denominator? The bottom line, read the problem. It's asking the what? The exact question was, how many grams of triamcinolone will you need to prepare this prescription? The pharmacy has received a prescription of 30 grams, which means that's the total. Why did I use grams over grams? Because I saw the word. Wait a minute. 2% means 2 grams for every 100 grams. Or if you saw that 30 grams of 2%, you can convert your 2% to decimal, which is 0.02 off 30 grams. Off means times. Is means equals. You remember? Elementary? There you go. 2 ways to do it. Okay. But this explains this back. Okay? So if you did it this way, you're starting to understand the concentration concept. Okay? Number 6. Similar for constitution problem. A 6-gram vial must have 10 ml of diluent added to it. Is that the total solution or that's just the water part? Okay. It has a powder volume of 2 ml. Okay. How many milligrams will be in each milliliter of the final solution? Can somebody erase the board? Leave the grams over grams, grams of ml over ml, the table on top. Yes. So the question is mg per ml. But you do know that your answer will be in grams per ml first, correct? Same banana, you just have to do an extra step because you want to answer the problem, right? Like in our example, never mind, just delete them all. Because
You sure you don't want to keep this?
no, you erased the other part. I said leave the table. It's okay.
Oh,
It's okay.
you told me to make
It's okay.
part.
I can write it again.
You did explain it.
Okay. What's your solute?
6 grams.
What's your denominator?
12.
Correct. Common mistake, people only use the 10 ml. That's why you have to read. The 10 ml is just the diluent part. But it told you the powder volume, which is
1.
2 ml. How much would that powder dissolve into? It told you 2 ml. So what's your denominator?
12.
So your numerator is all already in grams, so nothing to do there. 6 grams over, your denominator has to be ml. Over 12. 6 divided by 12 is
0.5.
0.5 grams per ml. But is that the question? So what do?
Compared to
Convert to milligrams, which gives you
500.
500 milligrams per ml. This is a similar problem as number 4. It's just that there's 2 different vials in number 4. You understand?
Yeah.
But number 6 is one scenario only. You get it now?
Yes.
I think you will remember that the denominator is total now, right? Not just the water part. Who got 500 mg per ml? To those of you who slapped this question on AI and found answers, you will not make it. Because you're not going to take this test on a laptop.
Who you joking?
Okay?
You're doing on
You
paper.
will take this test on a paper. And on the PTCE, you're not allowed to open tabs as well. Okay? So this is, I love technology. You know that by now. Okay? But it's how you use it. If you did this just to solve the problem, to submit it, that's why I don't care about the submission. I care about whether you understood it or not. Okay? somebody solved it for you. Okay? It's not gonna work. That's how you curtail your ability to learn. If you're using AI to research, that's an efficiency tool. But if you're letting it think for you, it's not good. No bueno. Right? What did we do? We have apps now. Alright? So a pro technology, but it's how you use it. Remember I told you, I'm not against you being on social media, but choose who you follow. First thing you do, check social media and look at your friends or quote unquote friends, what they do. Stop watching them. Start doing. Stop comparing your life to that. Instant formula for depression. And they only post the beautiful things in their life. So I hope no one used AI to solve this. My son hates AI.
Yeah, AI rules the world.
I said if you use it to research, it's fine, but if you ask it to answer your question, your homework, it's not fine. Okay. Who understood number 6?
Yes, I understand number 6.
Right? I have to say total for the denominator. Right? Do not forget that. Most common mistake is students only use the liquid part or the water part. The denominator for concentration will always be the total solution. That's why D5W means 5 grams of dextrose in a 100 ml solution of dextrose. Following?
Yes.
7. See how they're just flip-flopping the questions back and forth? But the steps are the same. It's testing you whether you understood concentration or strength of the drug. 7, Justin, show it on the board.
Oh. This is what I said.
Show us just that.
So what concentration is this? Grams over grams, ml over ml, or grams over ml?
Grams over ml.
There you go.
And
Can
you're
you solve
recording.
this using tic-tac-toe? Yes. Can you solve this using C1, V1 equals C2, V2?
Yes.
Yes. How do you do that? You can convert any strength into percentage. Just so you know, but if you're converting it to percentage, it should be grams per ml. So many different ways to solve this problem, right? Do the same problem on the other side of the board. I want to hear 2 different stories, if they're even different.
If you're even right.
You don't have to explain it yet. Just try to work it on the board and then talk to yourself or brainstorm in your own head. I always hear my son talking to himself. And I don't say, oh, don't do that. Jay said her son does that. You know, they did a study, the smartest people talk to themselves. Look, listen, Justin's talking to himself too. Yeah. He's explaining it to himself. Like, how do I understand this problem? You gotta do that. Can't wait for Justin to solve the problem or your student to solve the problem.
I have no idea if that's right.
Okay, keep going.
Oh, this is it right here. Because from my thinking, so 300 mg HB squared, I converted that, so I get 0.06 grams per 1 ml. And then I ratio proportion by the 2.5 grams, which is 41.67, but I'm assuming that's total volume. So, and then they have the outer volume of 9.6 ml.
Remember, there are multiple ways to solve this. Okay, there are multiple ways to solve it. Really, I wanted to solve it on one side. That's why I wanted different versions. I just told you, you can use 1v1 equals C2v2. You can use what? Tic-tac-toe as well. And what type of problem is this?
Conversion dosage.
Concentration of the reconstituted medication turns out to be 300 mg per teaspoon. Show the 300 mg per teaspoon. How you came up with 0.0.
So it would be.
That's how you should have started.
Yeah.
It's okay.
And then I just divide this,
Okay.
and then I'll turn it into. I was close.
It is right. It's just a rounding off.
Oh, okay.
One way to do it, how Justin did it. Good job.
So that's per ml, but even if that's
So many ways to solve this problem. So many.
just the most important thing is just converting that mg teaspoon into a 5. That's the only part. Okay, so so you wait for the portions to.
How can you use it in C1v1 equals C2v2?
So you have to find out the concentration,
In what? Find out the concentration in what unit?
grams per percent.
Or percent. Remember when I use C1v1 equals C2v2, I use percent in concentration. And how do you get to percent? How do you get to percent? Remember the 20%, my example earlier? That means 20 grams over 100 ml times 100. So how do you get to a percent? It should be grams over ml times 100. That's another way to solve it. But remember, it's only asking you which part? The water part. The water part.
I gotta do that. So 300.
I don't know if Steve is on.
So that's a teaspoon.
Oh, that's a different way. You do your way. There's multiple ways to solve this.
So I know you don't even have to convert it for the integration function. So and then I'll get 2.5 grams here. And then solve for x, so it's going to be the total. Right? So you do 2.5. Get 41.66. 67 if you want to.
Texting with Miss J. I'm actually glad Miss J gave me enough time. So we still have a lot to cover, like practice problems wise. The class isn't solid yet, I don't see. Who understood how Justin solved it?
I can do this. I have a question.
Okay.
Why do we subtract 9.6 ml?
Yes, because it's only asking you the water part. Look at the problem.
So the power
Oh,
volume
because
is
2.5 G with, because this is 9.6 ml.
How
That's the weight of the powder.
Read it. Read it. You'll have to read it.
I'm reading it. I'm asking you for reassurance too.
Yes, you have to read it. You have to read it over. If you have to read it over and over to understand it, read it over and over until you get it. Because it's a comprehension thing. No one will comprehend for you the word problems. You'll have to understand it yourself. Okay? So that's something which I told this to Maria back in the day. I said, I can teach you all the steps, but I cannot comprehend for you. So I told her, because one of her hurdles is language, right? I said, translate it in Spanish if that's how you understood it. But that's Maria, okay? So to you, you heard Justin, he was talking to himself. I told you, my son talks to
Well,
himself.
I know that. I was talking to, I talked to myself right now in my head, and I was telling you what I was
Your train of thought? Okay, do it again.
No, but now you
Do it again, do it again. Yes, I said yes, right? So the 9.6 you said is the powder volume.
Yes, so that's why you have to check because you're not, that's the total.
Yeah.
No, you're not for the total.
Yeah, and the question, no, that's not just for you, like in general.
Uh-huh.
Like
But
a
it
word
doesn't
problem,
matter,
yeah, a word problem, the first thing that you need to do is to read it.
Mhm.
Read it over and over until you understand it. And then start labeling it. Start labeling the numbers. Sometimes word problems have so many numbers and you don't have to use them all, right?
Yeah.
So read it. So she's verifying that is 9.6 the powder volume. Yeah, is that why you need to subtract that to your first answer? Yeah. Because what's the question? It's only asking you the water part.
We should do it like right
He's
here.
trying to do C1, V1 equals C2, V2. Who wants to try doing it in C1, V1 equals
Come do it.
C2, V2?
I know.
That's so confusing.
Rainy, if you're using C1, V1, I'll lead you to it.
Okay.
What should you do? Concentration, C1, V1 equals C2, V2. What do I use for concentration all the time? What unit? Percent, you remember, huh? Okay. Can I convert 300 mg per 5 ml to percent?
I
You
mean,
just talked about it.
if you make it grams,
Yes. So how do I convert this? Right? Justin just did it, right? Justin just did it. 0.06 grams per ml. Now can I convert that to percent? What did I do? Okay.
So let's see one.
Oh, that's
pretty cool.
There's so many ways to solve this problem. That's why I said I want people in the front different ways.
I like this way. I could see this way.
Can you see what I just did? It's like, that's why I keep flip-flopping. Back and forth, back and forth. Okay? Continue, Rainy.
So C1 is 6%.
Do your problem again if you have to.
The concentration of the constituted medication is 6%. So we Wait, you put a nitrous. Oh,
It's okay.
I'm not just.
Maybe you can't use this right away. I gotta get more. Okay. If you do 0.06 grams for every ml, what else do you have?
2.5 grams.
2.5 grams.
In the bottom 9.6.
Oh no. Maybe it's going to be harder to do C1V1 equals C2V2.
Mm-hmm.
Why? Because you don't have a second concentration right off the bat, right? You have to know the total first. Okay. So ratio and proportion could be your best bet. Because you're going to have to jump hoops to get the percentage of the second one, your C2. And you can't solve the C2, the concentration, the second concentration, without knowing the total. You following? Yeah. What is your X here?
41.67.
41.67. This is total? This is total, right? Okay. C1V1 equals C2V2. Now you can apply longer. I like this better because this will be long. Okay? It's doable, but it's longer. Okay? It's longer. You're going to have a volume. Okay? No, you can't use 9.6 because that's not total, right? You can use a 41.67 as your final, and then you're going to have an X percentage. No, for the first, because you don't know that percentage, right? You following? What's your initial volume now? And your initial strength will be 6%. But what's your initial volume for 6%?
The 5 value. Oh,
Okay. Longer, right? Longer, way long. Way long. So, it's okay, Rainy. It's longer. So your brain's gonna go like this before it come back to this answer. Right? You could try, yeah, but some people think like that. I understood it long way before I get back to here. Okay.
You got this.
You can stop now. You try, okay? Now we can stick to ratio and proportion. Try ratio and proportion first. If you see two concentrations right off the bat in percent or a fraction that you can convert to a percent, use C1V1 equals C2V2. If you see three concentrations, tic-tac-toe right away. Is that clear? Okay. What's the best solution for this number? Number 7, this one. Okay. Why is it that one? You're given 300 milligram per teaspoon. I can see a fraction in there. I can see that the milligram can be converted into a concentration such as grams per ml. and Justin did. So he converted 300 milligrams to grams, and he converted a teaspoon to ml. That makes it 0.3 grams per ml. You following? That is a concentration. Okay? If you divide that, it becomes 0.06 grams per ml. Now you can use it for ratio and proportion. Grams of solute over total number of solution, total amount of solution. You have 2.5 grams as weight of solute, but you don't know the total. Are you following? So you have to have that as your X. And by doing ratio and proportion, you came up with, oh, the total will be 41.67 ml. If you stop here, that's wrong. And you know what? Your multiple choice questions will have one of these. Yeah? Why is it the wrong answer? Because the question is, how much water only, not the total solution. Remember, this came out as the denominator. So you have to take out the powder volume that was given to you, which is 41.67 minus 9.6 ml. This is the water part. This is the powder part. This is the total. You can do reverse. Okay? So forget this. We tried, but it's going to be a lot of steps before we get back here. Okay? And I think this will be easier because it's ratio and proportion. But you have to understand that there's 3 different components. 2, at least, to make a different product. Okay? It takes 2 to make a different product. Your powder needs water to make it into a solution. Okay? So pay attention to the question. The correct answer is 32.1 ml or 32.07 ml. Who understood it? Okay. Now number A. Can you do tic-tac-toe?
Yes.
Yes. Can you do C1 V1 equals C2 V2?
Yeah.
No! There's 3 percentages I see. So straight to alligation or tic-tac-toe. Okay? Kathy, you did this yesterday, correct?
Yeah.
13 grams of 10% cream and 47 grams of 1% cream. Okay. Number 9. It can be easy. It can be easy. 30 grams of 15% cream, so 0.15 times 30 because it's in grams form already. So what is that in grams?
4.5 grams.
4.5 grams. What if the options are in milligrams?
Converted.
4,500 milligrams. Okay, another way to do it, I'll do it again. So you keep understanding. 15%, right? 15% means 15 grams over 100. Is it ml? No, grams, because it's cream. Ointments, creams. Remember semi-solids? 15 grams over 100 grams. That means 15%, right? What's the next? How many milligrams of the drug, that was a question, milligrams, so your answer should be 4,500, okay, are in 30 grams. So this is X grams over 30 G. I keep going back to this so you understand the concept of concentration. And this becomes 4.5 G. But the question was, how much is this in? Two ways, right? But me explaining it that way strengthens your understanding of concentration. Okay, next one. If there are 40 grams of dextrose in 500 ml of water, what is the percentage of the solution?
8%.
Yeah, grams, and you see a grams there, you see an ml there, times 100. Okay, 8%. Next one. How many milliliters of pure isopropyl alcohol are contained in 750 ml of isopropyl alcohol 91% solution. What process are we going to use?
No, well, C1.
Both can be used. Okay, one on the board, C1V1 equals C2V2, one tic-tac-toe on the other side. Who wants to do it? Okay, what are you going to do? C1V1 equals C2V2? Side, pay attention. What are you going to do?
Yes, C1V.
Okay, left side. Who's going to do the tic-tac-toe? You gotta grab a markers. Who's going to do the tic-tac-toe? Freshman.
Because he's a senior and a freshman.
Come on, Justin, do the tic-tac-toe.
Oh.
On the other side. It can't be Justin all the time, huh? I'm
Yeah.
gonna get more markers.
This is the only one. That was very good.
I said stay. You don't listen to verbal orders. Said stay right here. C1V1 equals C2V2.
Stay right here. Stay.
Stay right here. C1V1 C2V2. This one, tic tac toe. What, Rainy? Hold on your hair. What do you got on markers?
God, it's not
So this is, oh, wait.
We did this one.
Yeah, we did this one yesterday.
I don't know why we do it again. Okay, hey,
Wait.
but I want to just do it on the board so I don't get called for a heart.
How did we do it? We did A and 15.
No, yeah, we did this one.
100, 0, 91. 91's on top. Drop this down. 91. This is, wait, 900.
Good split.
Okay. Sorry. Over 91. Bam. 6, 8, 2, 5. Oh, the extra markers.
Please throw away the ones that don't work. Okay. C1 pure. C1 pure, so 100%. Okay. The problem is the number 11. How many milliliters of pure isopropyl alcohol are contained in 750 ml of isopropyl alcohol? Isopropyl alcohol 91% solution. Pure 100% C1. What's your volume 1? You don't know, right? What's your C2? You're making it from 100% concentration, diluting it to 91% concentration. But you're given a volume for the 91%. 750 ml. 91 times 750 divided by 100 is 682.5 ml. You saw that?
Yeah.
Okay. Just to prove that you can use tic-tac-toe, okay, if you use pure 100% and water 0, okay? Pure is 100, water is 0. What are you trying to make out of water and pure? 91, okay? Tic-tac-toe, 91 minus 0, absolute 91 parts. 100 minus 91, 9 parts. Bring it down so you know that that's 100 parts, right? Then you can proceed with ratio and proportion. Okay. 100 parts is to 750 ml is to 91 parts is to X ml. Follow?
Yeah.
Who liked the C1V1 equals C2? Who did the tic-tac-toe?
I didn't see one.
That's okay. As long as you know what to use for pure, and as long as you know what to use for water. Remember, 2 concentrations. C1V1 equals C2V2. 3 concentrations, tic-tac-toe. How did we come up with 3 and use the tic-tac-toe? Because we saw pure and we saw water to dilute it. Or whatever base. It doesn't have to be water. Okay? Vaseline can be at 0%. You following? Any base. Okay? Next one. Number 12. You must add 9 millimoles. Millimoles, oh my God! Just use it as any, just like any unit. Okay? Of an inorganic phosphate to an IV solution. You have 15 millimoles per 5 ml available. How many milliliters should you add?
3
Correct! 3 ml. It's a simple ratio proportion. Number 13. Last one then break. Okay? A patient receives an IV solution containing 500 ml of a 10% IV fat emulsion. How many grams of fat did the patient receive? 10%. You can do it, ratio proportion, you know that, right? Again, what does 10% tell you? What does 10% tell you? Hey, I'm 10 grams for every 100 ml. Yeah? Yeah? And this is? It can be as simple as that. Hey, I'm 10%. So that means I'm 10 grams for every 100 ml. You following?
Yes.
Who understood it? Write this right here.
Wait, so, what was it?
50 grams.
That's good.
I never had one.
Oh.
It's always 50.
We will continue. I will see you guys at 10:30.
Okay.
Make sure.
I feel this C1 and B1 C2 was really more simple for me to do the calculation.
But you can't use that all the time. You can't use C1V1 equals C2V2 for all the problems. Okay, it's only for 2 concentrations. It's a dilution formula.